Hello everyone. In this video, we are going to learn about different problems based on nodal analysis. Okay, so this is the first problem. So in this problem, we are supposed to find the power supplied by 10 volt source. Okay, so first, in order to solve this problem, we need to assume the nodes. Okay, so let me erase this part. Okay, so this is the first node. This is the second node, and the bottom line is our reference. The reference voltage is always 0 volts. And let us assume the node voltage is like V1, V2. Okay, so at each and every node we are supposed to apply KCL to find the nodal equations. So while we are applying KCL, we need the current directions. If in any given problem, if you are not given with any current directions, then you take always leaving from the node that particular element's current direction. Okay, so now let us start with node 1. Okay, node 1. We are going to apply KCL. So because this is the first problem, I'll explain in detail and later on we'll do it directly on the problem. Okay, so consider node 1 and you draw the elements which were connected to node 1 alone. Okay, so 2 ohms. Here is a source minus 2 plus 10 volts, and this is 4 ohm resistor, and this is a current source. This is 10 ampere, and we forgot one more resistor is there. Okay, so this is 2 ohm. So this particular point is node 1 whose voltage is V1, and default we got node 2 whose voltage is V2. So I already told you if the direction is not specified for you, so take the current direction as leaving from the node like this. Okay, so now we apply KCL. So current passing through 2 ohm plus current passing through 4 ohm plus current passing through 2 ohm. So this first 2 ohm is there, no? So this is the element which is connected between node 1 and node 2, and the second one, so this current passing through 2 ohm. So this is the element 2 ohm resistor which was connected between node 1 and reference. Okay, so are there any other branches? Yes, 10 ampere current source is there which is also leaving from node 1. So take plus 10 equal to 0. Clear? So now what is the current flowing through 2 ohm resistor according to node 2? According to node 1. So because we are considering node 1, V1 has to be our reference, so V1. The other voltage has to be subtracted, so that we'll be getting the voltage across 2 ohm resistor divided by resistance 2. So V by R. So this is the current passing through 2 ohm resistor plus what is the current passing through 4 ohm resistor? So take V1 first. So here in this branch you are having a voltage source according to the current direction. So first you are getting minus polarity for the supply. So minus of minus, it will be plus 10 minus V2. So this is the voltage across 4 ohm resistor divided by 4. There is a current passing through 4 ohm resistor plus what is the current passing through 2 ohm resistor which was connected between node 1 and node 0, that is V1. So here the voltage is 0 volts. So what is V1 minus 0? So simply V1. So V1 by 2 plus 10 equal to 0. So if we can solve this particular equation, we'll be getting equation 1. So and the equation is 1.25 V1 minus 0.75 V2 equal to minus 12.5. This is equation 1. So let us have node 2. Okay, right. So here we consider node 2. So again we are supposed to apply KCL. Consider node 2 and draw the elements which were connected to node 2. Okay, so here is the dependent current source. This is 4V3. One more resistor is there. This is 1 ohm. One branch is there. This is minus 2 plus 10 volts, and this is 4 ohms, and one more element is there. This is 2 ohms. So this particular node is node 2 whose voltage is V2. This is node 1 whose voltage is V1. So if the direction is not specified, take always leaving from the node. Okay, so now you apply KCL. That means current passing through 2 ohm resistor plus current passing through 4 ohm resistor plus current passing through 1 ohm resistor is equal to this dependent current source is there, no? So you can observe the direction of that. So that is entering towards node 2. So which is equal to 4V3. Okay, so now what is the current passing through 2 ohm resistor according to node 2? So this is V2 minus V1 by 2 plus current passing through 4 ohm, that is V2 minus 10 minus V1 by 4 plus current passing through 1 ohm, that is V2 by 1 is equal to 4V3. Clear? So now what is V3? Because we got two equations with three unknowns, it is difficult to find. So look at the problem once. Okay, see what is V3? V3 is the voltage across 4 ohm resistor. So look at the polarities. So plus minus. Clear? So that means we consider the same V3 here so that it is easy for us to do the calculations. Okay, so this is plus 2 minus V3. So if we can able to solve V3 in terms of V1, V2, so we will be getting the equation in terms of V1, V2. Okay, let us see. Now I'll be redrawing here 4 ohm resistor. I was supposed to find the current through 4 ohm resistor. So why I consider this direction? Because the polarity is given like that, plus to minus. Okay, so this 4 ohm was connected to a battery of 10 volts. Okay, this is node 1 whose voltage is V1 and this is node 2 whose voltage is V2. Now in this direction, what is the current? The current passing through 4 ohm is nothing but V1 plus 10 minus V2 by 4. This is the current. So now can we calculate the voltage drop across 4 ohm resistor now? Yes. So voltage across 4 ohm resistor is nothing but current passing through 4 ohm into 4. There you can get V1 plus 10 minus V2 simply. Is that not equal to V3? Yes. So now you substitute this particular relation in this particular equation. Okay, so there you get the equation in terms of V1 and V2. Okay, so I'll be writing that equation minus 4.75 V1 plus 5.75 V2 equal to 42.5. Equation 2. Okay, so now you solve equation 1 and 2, so you get V1, V2. Okay, solve equations 1 and 2. So V1 is minus 11.03 volts and V2 is minus 1.724 volts. Okay, so is the problem is over? No, we are supposed to find the power supplied by 10 volt source. Okay, so power delivered by 10 volt source, that is V into I. What is the voltage? 10. You don't know the value of current I. Okay, so here only we can observe. So this is the current, no? This is the current which is coming out from 10 volt source. Yes. So we can have this particular current instead of I. Okay, so this is 10 into V1 plus 10 minus V2 by 4. You got the V1, V2 values, substitute. There you can get the value for power. So, and the value is 1.735 watts. Clear? So now let us do the second problem. Okay. Right. So we'll go with the second problem and quickly I'll draw the network. This is 3 ohm resistor. Here is a voltage source. We don't know the value of that. So again here we got one more resistor of value 2 ohms, and then 10 ohms, and then 5 ohms, and then 7 ohms. Next, plus 2 minus 50 volts. Okay, so in this particular problem, we are supposed to find the voltage value V under some conditions, and the condition is when the current passing through 10 ohm is 0, we are supposed to find the V value. Okay, let us solve the problem. Okay, for that we need to identify the nodes. This is the first node, second node, whose voltages are V1, V2. So this is the reference whose voltage is 0 volts. Okay, so consider node 1 and apply KCL. Okay, here I'm not redrawing the network, directly I'm solving. Okay, so direction not specified, take always leaving from the node. Okay, so now the current passing through 3 ohm plus the current passing through 2 ohm plus the current passing through 10 ohm equal to 0, because no other entering currents are there. So this is V1 minus V by 3 plus V1 by 2 plus V1 minus V2 by 10 equal to 0. So if we can solve this equation, we'll be getting equation 1, and the equation is 1 minute. I'll be solving that. I just solved that one. So right. So the value is 0.93 V1 minus 0.1 V2 equal to V by 3. So this is first equation. Now you consider node 2. Okay, so again you apply KCL. Clear? So I'll take another color. So direction not specified, take always leaving from the node. So now this is current passing through 10 ohm plus current passing through 5 ohm plus current passing through 7 ohm equal to 0. No other entering current. Okay, so what is the current flowing through 10 ohm resistance according to node 2? This is V2 minus V1 by 10. Current passing through 5 ohm, V2 by 5. Current passing through 7 ohm, this is V2 minus 50 by 7 equal to 0. So if we can solve, we'll be getting another equation, and the equation is minus 0.1 V1 plus 0.443 V2 equal to 7.143. So this is second equation. So how many unknowns are there? 3 unknowns, because V1, V2, V is also there. Okay, it is difficult to solve. Now you observe the condition. What was the condition? Current passing through 10 ohm is 0. So we apply that condition. Okay, so given condition. So the given condition is current passing through 10 ohm is 0. So what you wrote the equation? What is the relation for current passing through 10 ohm? Is it not V1 minus V2 by 10? Or you can consider here also. Okay, you're having V2 minus V1 by 10. It doesn't matter. So you'll be getting plus or minus difference. Okay, so if you got minus sign, it means whatever the assumed direction, so that was wrong, and the current was flowing in the reverse way. That's it. The magnitude of the amount of current will be same. Okay, so I'll go with the first one, that is V1 minus V2 by 10. Okay, so now V1 minus V2 by 10 is the current passing through 10 ohm, which is equal to 0. So V1 minus V2 equal to 0. So this is the third equation. Now you solve all the three equations. You'll be having the values for V1, V2, V. Okay, solve 1, 2 and 3. So that you get the V1, V2 and V3 values. And we are supposed to find what value? It's not V3 but is V. Okay, so this is V only. Okay, so the values are 20.83 volts. Again you got 20.83 here, and here V is 51.87 volts. Okay, in this way we can solve the problem. Okay, so let us solve the next problem. Okay, so we'll have the next one, another simple problem. So this is 3 ohm resistor. There you got the supply 20 volts, and then 1 ohm. This is 5 ampere. Next 6 ohm, 2 ohm, and then 5 ohm. Okay, so this was the network, and in this problem we are supposed to find the power dissipation by 6 ohm resistor. So this is the problem. So let us see how the problem can be solved. So in order to solve this particular problem, we need to find the nodes first. So this is the first node, and this is the second node, and this is the third node, and this bottom line, this is the reference node whose voltage is 0. Now node voltages, assume V1, V2, V3. Now consider node 1. Okay, apply KCL. Okay, so current direction not specified, take always leaving from the node. That's it. Okay, so now the current passing through 3 ohm plus the current passing through 1 ohm plus the current passing through 2 ohm. No entering currents, so equal to 0. Now what we can do now? What is the current passing through 3 ohm resistor? This is V1 minus 20 by 3 plus this 1 ohm is connected between node 1 and node 2. So that means V1 minus V2 by 1 plus current passing through 2 ohm resistor. This is V1 minus V3 by 2 equal to 0. So the equation will be, okay, now this is 1.83 V1 minus V2 minus 0.5 V3 equal to 6.67. This is equation 1. Consider node 2. Okay, right, node 2. So take the currents which are leaving. Okay, if the direction is not specified, this is leaving, this is also leaving. Now apply KCL. Okay, so that means the current passing through 1 ohm resistor plus the current passing through 6 ohm resistor, these two are the leaving currents. What is the entering current? 5 is the entering current. Now what is the current passing through 1 ohm resistor according to node 2? This is V2 minus V1 by 1 plus current passing through 6 ohm, that is V2 minus V3 by 6 is equal to 5. So solve this equation, we'll be getting the second equation. Okay, the second equation is minus V1 minus 1.167 V2 minus 0.167 V3 equal to 5. This is the second equation. Now go for node 2. Okay, it's not node 2, node 3. Now consider node 3. Again apply KCL. Okay, so I'll pick another color. Okay, so see here, this is the third node, direction not specified, so take leaving from the node. Clear? So that means the current passing through 2 ohm resistor plus current passing through 6 ohm resistor plus current passing through 5 ohm resistor equal to 0. Okay, now what is the current passing through 2 ohm resistor according to node 3? This is V3 minus V1 by 2 plus current passing through 6 ohm resistor, that is V3 minus V2 by 6 plus current passing through 5 ohm resistor, that is V3 by 5 equal to 0. Okay, so now if we solve this equation, we'll be getting minus 0.5 V1 minus 0.167 V2 plus 0.867 V3 equal to 0. Call it as equation 3. Now, if we can able to solve these three equations, we'll be getting the values for V1, V2 and V3. Okay, V1, V2, V3. After solving 1, 2 and 3. So once we got the values, okay, so once we got the values, then we can able to find the power dissipation through 6 ohm resistor. So this is the problem, right? So see, once the network, so this is the 6 ohm resistor, right? So I'll be drawing here. This is 6 ohm resistor. This was connected between node 2 and node 3. So whose voltages are V2 and V3. Clear? So if in any element, if the direction is not given to you and you are supposed to find the power dissipation especially, so consider the current like this, left to right. Or the element is like this, okay? So consider the direction, finding direction as top to bottom. Okay, so here we consider this direction. So in this direction, what is the current? Is it not V2 minus V3 by 6? Yes. So have that current relation here. Okay. This is V2 minus V3 by 6. This is the current through 6 ohm resistor. So power P is equal to VI or I square R or V square by R you may take. Okay. So here I am considering this relation I square R. This is the current. So have the square into resistance is 6. So once you got here we got V1, V2, V3 values, right? So and the values are this V2 minus 4.93 volts and V3 minus 0.47 volts. Okay, so now you substitute those values, you'll be getting the power dissipation in 6 ohm resistor as 3.29 watt. Okay, so in this way we can solve the problems based on nodal analysis. So thank you so much for watching this video. Okay.